दोस्तों जय हिंद जय भारत नमस्कार. During this particular session we will try to understand the leakage current issue and leakage current generated by the variable speed drive. This particular video is a purely an educational video and there is no relation with any company product or any marketing. So this is only a purely an educational video. During this particular video we will try to understand the leakage current generated by the VSD, and because of this leakage current the user are facing many issues related to the tripping of the upstream breaker, tripping of the side by equipment, tripping of an environmental in the same custody at the same power coupling at the PCC. The other equipment may affect. And what are the solutions if we have faced such type of an issue? So today we will try to understand how the leakage current is being generated, and in the second part of this particular session, I will try to explain the how the leakage current can be calculated. So these are the two major topics, but during this particular session, we will try to understand the VST leakage current issue, and this is the solution and what are the solutions. Sorry. So before going to that, what went wrong at the point of common coupling? We called it as a PCC. So at the point of common coupling, how the VSD, this is the point of common coupling. Let me try to explain. And with dV by dt switching at the IGBT with the cable capacitance and motor capacitance, you can see this is a fantastic drawing what I have mentioned on the screen. From the left side point of common coupling, there is a rectification, and again there is a problematic equipment which is nothing but our switching, that is IGBT or any other IGCT. So with this type of switching and with the cable capacitance and motor capacitance in the air gap between the stator and rotor and having a fantastic capacitance at the motor too, you can see here by addition of high switching frequency by high dV by dt, the cable capacitance, the motor capacitance will resulted into high leakage current. And this leakage current, you can see it will flow through this power. This is from the bottom side, you can see the high leakage current will flow through the P conductor, sorry. And through this P conductor, you can see it is passing through the source. And if the source, you can see here, this is a point of common coupling. The leakage current is passing to the source, and from this point of common coupling, it should go back to the source. As a common practice, the leakage current generated by the VSD equipment should again go to the source, and that is called a good ideal closed circuit. But in this particular case, it is not going to the source. In our case, the source is inverter, but it is not going back to the inverter. It is going to the transformer neutral, which is absolutely at a grounded potential. And then you can see this leakage current is affecting the same connected load on the PCC, the point of common coupling. And now if these equipment are quite sensitive equipment, this can be malfunction, tripped, and it may be an asset loss. This is the biggest problem with the variable speed drive nowadays. People are facing with a large population of the VSD. Now, how can we avoid such type of issue? VSD is required for many other reasons, but if you use VSD without any filter at the input, you can see here this high leakage current will pass through the transformer source neutral, and if the other equipments are being connected at the point of common coupling, there is a chances of malfunctioning, tripping of the other equipments also, especially the electronic sensitive device. Now in this type of what are the resolution, जैसे मैंने आपको बताया. Now let me try to explain the same circuit. In this circuit I have mentioned two filter. One filter just connected at the input of the rectifier, and the second filter is an optional filter. Many good customer are used both the filters. Let me try to explain. You can see here now. I mentioned in the last sheet, that is the leakage current should go back to the source. In our case, the source is IGBT or inverter. Now you can see here this high frequency leakage current is passing through the PE conductor, and the filter are absolutely tuned to absorb it, offer very less resistance instead of going to the source. You can see here. Now I will explain with the same circuit. You can see here this leakage current is passing through the filter, VSD line filter, and one additional filter what I mentioned at a compliance C2. Many good customer are suggesting one more filter at the just after the power of common coupling entering to the VSD. And you can see here the EMC filter offer very less resistive path. So instead of going to this particular power of common coupling, uh, you can see here the current is back to the source. आप देख सकते हैं कि यहाँ पर back to the source, the leakage current is passing from the uh, P conductor to the EMC filter, and then it is back to the source. In this case, the most precaution is your filter must be tuned accordingly to the frequency of the leakage current. This is the most, and that is why normally we procure this line filter from the OEM only, because they are the very best calculation how much leakage current will be flowing with a proper frequency. So this is how we can avoid. You can see here in this particular case it is passing through the conductor and going back to the source, and in this particular case power of common coupling, there is no issue at all to the side by customer, and in this particular case the electronic systems are healthy. Now what are the learnings? Let me try to put all the learnings on the single page. So this is the two filter, uh, environmental C3 compliance and one additional in case of more than one VSD are been connected. So many good customer, many good user are using additional filter at the upstream of the VSD also. Now what are the learnings? The learnings number, if you are facing unwanted tripping of PCC connected load, side by connected load are facing the unwanted tripping without any reason, you will reset and restart, it will run for the few days and then again it will trip. This is the bus bar hitting at the PCC because of the high switching frequency current flowing continuously through the bus bar. The joints are been again it is been abnormal hitting will be observed at the PCC bus bar. System needs reset frequently. That means the side by system required to reset frequently. You could not find out the exact problem, and then the system run for the few days, few months, again it trips. So these are the additional problems, and then at last you must have to go to check the quality of the point, quality of the power at the point of common coupling. This is the best solution, and by checking the quality of the power at the PCC, that means point of common coupling, either it's a MCC, either PCC, or any other PMCC type of arrangement, we must have to check it. And with this particular checking, we need to tune our filter so that it will not affect the side by equipments. So with this small presentation, we will continue. Now the next session, I will try to explain how the I leakage current is flowing. Sorry, how can we calculate the I leakage current? Thank you. धन्यवाद.